Welcome to the Maintainable Software Podcast, where we explore the art of improving existing software with seasoned practitioners who have helped organizations overcome the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, Alan Ridlehoover, who is currently a senior engineering manager at Cisco Meraki. Alan joins us from the California Bay Area, not too far from where I grew up. Alan Ridlehoover, we're so good to have you join us on Maintainable. Welcome.
Thank you.
So as you reflect on your experience in the industry, what do you believe are a few common characteristics of, dare I say, well-maintained software?
Well, first of all, I have to say I absolutely love this question. People ought to be asking it of themselves every day and asking themselves where are the gaps in their current system. Personally, I think there are three components of really well-maintained software. I think you need robust behavior-centric tests that document why the software does what it does. I think you need code that adheres to the single responsibility principle and the open-close principle. And I think in large organizations in particular, you need really clearly defined ownership boundaries with well-established APIs between things. For me, those are the things that lead to well-maintained software.
And for some context for those listening, what size engineering teams do you tend to find yourself working in?
I work at Cisco Meraki. We have about 1,000 engineers working on a Rails monolith that's about 2 million lines of code with a JavaScript monolith on top of it that's about 2 million lines of code.
And so do you think the definition of well-maintained software might be a little different in that context to, say, a startup?
Oh, for sure. Although I will say maybe the ownership boundaries are a little bit looser at the startup level, but I don't know that moving away from behavior-centric tests and sort of solid code, like the single responsibility principle, the open-close principle, I think those will serve you well anywhere. I think that they'll actually help you move faster as well, which is often kind of misconstrued, both at the startup level and even at the enterprise level. People think that they can move quicker by ignoring those things, when in fact, over the long term, you're going to move much faster when you have those things.
Have you had many opportunities to work kind of early on in that MVP phase where you're just trying to see if this is going to find product market fit and then finding that boundary of like, how much should we invest in the future when we don't know if a future exists?
I've spent probably half my career in startups. I've definitely had that experience of working in an area where you're not even sure that that's the direction that business is going to go, or you've had to pivot really quickly. In those scenarios, I do believe that the more code you throw faster, kind of the better for the business. The more different options you can give the business more quickly, the better. I think that there's a value in understanding what it is you're trying to build, and that's where behavior-centric tests come in. I do believe that if you're writing implementation-specific tests, you're shooting yourself in the foot. Those will get in your way no matter what you're trying to do. And I think that if it's a script that you need to wire two things together to get some code from CI to production, maybe there's a different bar for that code. But when I am working to put something that I have requirements for on the web or wherever it is it's going, I feel like I'm fastest when I'm thinking about really clear requirements that I can express as behavior-centric tests and really focused on clean object-oriented code. Here's what generally happens. You build a feature and the feature works great and now you're going to ship it and then the customer says, oh, but I really meant this, or in this situation, I'd rather have that. And so your second step is to maybe come back into that code, maybe add an if statement, and typically over time, those if statements build up, conditional statements become a real challenge, and that's when code becomes very complex very quickly, and there's a benefit at that point to kind of untangling it's actually, I use a process I call rehydration, where I flatten the if statements, put all the conditional logic back, all the repetitive logic back into the various parts of the if statement, because oftentimes people are creating these if statements around like drying up code. They'll take some code that's pretty wet and they'll dry it up and they end up with conditionals about, well, in this condition, execute these 3 lines of code, but in that condition, don't execute those 3 lines of code. So I'll rehydrate it. I'll put all that back in. And what often occurs to you when you see that is like, oh, there's an abstraction here that's missing. And if I add that abstraction, Now, the next time I need to add another one of these things, I'm just creating a new class. I'm not adding more conditional logic to the existing class. So in that environment where I'm moving quickly and I'm trying to put something out quickly, I may make a short-term decision to increase the complexity of the code in order to get it out super quick. But I almost always regret that within 10 minutes. And I would much rather in fact, sometimes it takes doing that to get to the point where you can, like, okay, I need to unwind this, I need to find the abstraction, but the abstraction wasn't clear up front. And so you needed to put the conditional logic in place in order to see the abstraction. But once it's there, once I see it, I want to move to it as quickly as possible, as long as I'm confident that it's the right abstraction. Because if I put the wrong abstraction in place, it's going to have a deleterious effect on the future of the software. It's often harder to remove a bad abstraction than it is to wait and then get the right abstraction in place.
So like that early on, we get these initial set of requirements and you're thinking about, there's that kind of balance, that delicate balance of pre-optimize, like, well, this is what we know right now. And then until the user sees it, or the customer, whoever's requesting the thing that you're building, they end up having to react to it. Like, well, that kind of covers most things, but there's also this other little thing that we need to think about. And then you get some more feedback and you start making changes. And so you could try to design that up front and thinking like, here's all the possible ways that this might be used one day by different customers that do or do not exist yet. And that's a difficult thing to navigate. So you're kind of advocating for keeping it kind of simple first, allowing yourself to introduce a little bit of complexity, and then just kind of keeping an eye on that until you go through this process, be like, okay, but now we need to introduce some better abstraction here because I feel more confident about how this is going to be used going forward to some degree.
Yeah, process, especially in that startup environment, I would really, really hesitate on is any kind of big upfront design. You're spending time thinking about things that are not relevant. Only write the code that's in front of you. Stay in the moment. Don't try to predict. If you have a particular feature in front of you, build it. If you have another second feature in front of you, evaluate the first feature, see if there's room for the second feature, refactor if not, add the second feature and move on. But if you're trying to think about every possible scenario that every future customer might want, you're wasting your time. You may not ever get to that like the software might pivot before you even get to those challenges. So just stay focused on what's right in front of you.
Hey folks, it's me, Robby. I want you to take a moment and close your eyes. Now picture your code and your applications as a symphony. Now to keep that symphony playing smoothly, you need an orchestra of tools. That's where our podcast sponsor, AppSignal, takes center stage. They combine the elegance of error tracking, the precision of performance monitoring, and the harmony of logging into one symphonic suite. Whether you're composing with Ruby, jamming with Elixir, orchestrating with Node.js, or harmonizing with Python, or maybe even a little bit of flourish of JavaScript, AppSignal's got the sheet music for you. And here's the crescendo. Plans start at just $23 US a month. That's gotta be music to your budget's ears. Plus they're certified ISO 27001 and they dance the GDPR and HIPAA compliance beats. So don't miss a beat, my friends. Head on over to appsignal.com and tell them that your good friend Robby from Maintainable sent you. Now, open your eyes and let the symphony of smooth coding begin. Let's get back to our show. Something I hadn't thought about bringing up with you in our conversation, but this got me thinking a little bit about dependencies. So like, you need to build a set of functionality and there's maybe some open source libraries that might accomplish part of what you're doing. How do you think about bringing in those sorts of dependencies and how that might help you right now? Or they may be like, well, this particular integration with this open source library is going to give us a lot of options in the future that we may need. So let's use this one, but you don't know that you need them yet. So how do you think about that sort of thing when you're bringing in something where you might not be able to refactor that external library and then you're kind of like settling in like, well, this is what the choice we're making because we're going to get something out the door a little quicker and we might take advantage of this. How do you kind of navigate that with your teams?
Yeah, it's a great question. I think that the trade-off between building your own, finding a very small, discrete thing that helps you, or taking on something larger and more general really boils down to how well can you, well, first of all, how quickly could you build what you need right this minute and stay in the moment versus is there something that just does exactly what you need right this moment versus, again, if you're going to think ahead, if you're trying to like plan for the future, one way that you can insulate yourself from that decision and then later bring in something more complicated if you need it, is to make sure you're using interfaces in front of these things. So if you've, for example, if you're using a queuing technology today that will only scale to a certain level, and you predict that in the future you might need more scale, putting some kind of an interface or facade in front of that queuing interface gives you the option to later swap it out for a different queue, so you can scale at the rate that you need to. So for example, if you are today, I don't know, let's say you're using Amazon SQS for queuing, and later you decide to move to something much bigger, much that has much more scalability, say Kafka or something. If there's a single point of reference that your application uses to talk to that thing, you can actually have both of them behind the scenes and have a feature flag that switches back and forth. You can run them in parallel to test that the new system is working as expected. There's a ton you can do just by putting that facade in place. And if you think about that up front, you're going to save yourself a lot of headaches, because what tends to happen over time is that you would have many different points that talk to the queue. And if you're having to go back and replace every single one of those individual points when you switch, that's the definition of unmaintainable, in my opinion. Like,
I think about that quite a bit when it comes to, we both work in the Ruby on Rails ecosystem, and some of our clients will come to us and they'll have, let's say, integrations with Stripe or something. And then our client's like, hey, we want to integrate with PayPal. And we're like, okay. And then we're like, well, do you know how many times there's like a Stripe reference in your database columns? And it's permeates over just like, you got to use this one library that helped you get off the ground really quickly, but this is a really they're like, why is this such a big expensive thing just to add another payment gateway into this? And you're like, because your original developer made that decision to, yes, integrate with Stripe, and they used the Stripe thing, and that had a bunch of migrations that came with it. You got all this stuff out of the box. There was no abstraction. So you're kind of coupled there at the moment, and that's a tricky thing to kind of sort of navigate. And then, clients don't often understand why this stuff is so much more complicated in the future, right? Why does it cost more to integrate with PayPal than it did originally with Stripe? Fun conversation to have. Be that as it may. So a couple other things things I want to talk about. Let's pivot a little bit, talk about technical debt. And do you use the metaphor technical debt very often? And what's your kind of take on that at the moment?
I have used the metaphor for technical debt for years. I've met Ward Cunningham, who came up with the term, and I've talked to him about it. It's an interesting metaphor. And I was also talking to Jason Sweat recently about there is a cost associated with code that is less maintainable, let's call it. So to not use the term for a moment. That cost is, I'm actually fond of the metaphor. I'm fond of the idea that you're paying interest on that code until you come back and address it. So where you have a bit of code that you've made that decision early on to accept some complexity, to not invest in paying it down at the moment because you're making a trade-off. I want to move quickly and maybe don't have time to find the right abstraction right this minute. Maybe there's a giant deal on the table that if you can get it done this week, it might make a difference. And I'll tell you, that doesn't just happen at startups. That happens at enterprise companies too, where we have a large customer who wants a particular feature by a particular date, and they'll sign on a much larger contract if we get the feature to them. Or we're in a competitive landscape, we're trying to win a bid. So if you're in a startup and your sales team is pestering you about a particular feature, know that still happens at the really big organizations too. So in that situation, and where you need to get something out quickly, I do believe that it's all right to take on some technical debt, as long as you're aware of it, as long as you're doing it consciously, and as long as you have a plan for paying off the debt, like paying it down later. What often happens, and I think this is a challenge with communicating back to the business more so than a technical challenge, what happens is there's another deal right behind that one, and another deal right behind that one. There needs to be a healthy communication mechanism between the business, both sales and support and product, and the engineering side of things, where all of those different inputs, sales, support, product management, engineering, all of them are taken into account as you build your roadmap. And so if there are bits of debt that need to be paid down over time, those things need to be reflected in the roadmap. This goes back to the conversation I had with Ward. I was asking him, how do you talk to somebody about paying off that debt? How do you convince them that that's the most important thing to do? And he says, I don't. I just tell them when they ask me for the new feature, I say, well, I'll need this much time to make room for that feature, and then I'll need this much time to add the feature. And he doesn't use the debt metaphor himself when he's talking about it with his customer. Well, he may, but in his conversation with me, he talked about making room for the feature within the existing software, which is paying down that debt.
I like that kind of the framing around it. One of the challenges that I notice when I'm working with different clients of ours, when they have their own internal engineering team, that there's usually like they have like their team's product backlog of things that they're working on coming down, that's maybe coming from the product team, new things for their customers, but then they've got their own kind of list of wherever that might be, another backlog of technical debt type things, and they're logging those like, hey, and they're trying to prioritize that and figure out we got some amount of time to address these things, but sometimes prioritizing that can be challenging for different reasons. There's, as you said, there's always another deal coming down the pipeline. And then with the challenge sometimes being that I worry that is like everybody putting that into the same bucket, it becomes more difficult to kind of like, well, what types of technical debt? Then we're trying to break that down and explain it. And I'm like, I don't know sometimes I think sometimes I hear some people say technical debt is really easy for the product people to understand because they understand this concept of debt. But then I also think that we can overuse it in a way that it's like, well, if everything falls into it, they're like, is there anything that we're not asking you to do technical debt? Like, where's that delineation between things that you need to do to make room to add this feature, things that are upgrades? Like, and are they consciously saying, please never upgrade your app or never deal with those things those compromises you made? There's also teams that maybe don't know how to communicate effectively when they're making those trade-offs, or they make the trade-offs kind of in private, like because they're just trying to ship something out the door and they're like, all right, well, we got to get this out by Friday and we're running late on our estimate. We're not going to get this done unless we make this compromise. Did they vocalize that? Did they share like, hey, we needed to do this, but they're just so focused on getting the thing out the door that now ends up on a list and the product people don't know about it. And they're like, hey, we made this thing. You made us get this thing out the door. And so then it kind of is like a little bit of a finger pointing thing when they're not really taking ownership of like, well, we actually made that decision. We didn't ask, can we get extra time because we didn't think that you would say yes to it. So this is like a challenging thing that I think a lot of people are navigating, especially like in small teams. They maybe not have the experience level to feel confident enough to say, okay, for me to do this, I'm going to need to make room for this to do this and give you a reliable time frame or estimate. And so how do you think about that with your team or communicate that with your team? Like when I'm assuming estimates of some sort are asked for, like, can we accomplish it in a time period? Or are you thinking about that with story points? Like, how does your team kind of approach that sort of stuff and squeeze that stuff in or sneak it in? Or I'm air quoting sneak it in, but that type of work.
So I have, I don't know, I think 7 teams now that report to me, and they all have different approaches to that. The approach that I've found most effective and have used directly when I'm managing a team directly is to use sort of a count of the total number of tickets that are in the backlog versus using story points. I think story points are interesting from like the concept of getting everybody on the same page about something. If you're using like planning poker and you've got 2 or 3 different estimates that are wildly different, there's a conversation that needs to happen there. Like get everybody on the same page about what this thing is. But just from a velocity standpoint, I've actually found, because a lot of people don't actually include bugs, they don't point bugs, for example, and often those tickets, what I found in my experience was that you're great at predicting your velocity up until the month before the deploy, and then you deploy somewhere and there's like a ton of bugs all of a sudden, and now you can't predict your velocity. So I've gone to a straight just count the number of tickets. And I assume that over time, they'll kind of all average out to roughly the same size. Some will be bigger, some will be smaller, but on average, though. And I've proven that in like watching the data. So my teams tend to move towards 3 points, like 3 story points per ticket. Some are 5, some are 2, some are 1. But in general, it seems to average out to about 3. And once I realized that, I'm like, well, I'm just going to count the tickets. And so being able to express the backlog in a small enough form, the tickets broken down to like that 3-point level, maybe 1 to 5-point level, gives me the ability to accurately predict where we'll be at a certain point in time. I know what the team's velocity is. I know how many tickets are in the backlog. I can tell you we'll be here in this state and be pretty accurate with that. Even at the quarter by quarter level, I've been pretty accurate at that. What's difficult and what you don't always have the time to do is to sit down and think through, all right, here's the feature. Here's every piece of the feature we want to build. And again, that might be too much. That might be thinking too far in advance for a small company. Maybe the feature is some reporting feature. And really all the customer needs right this minute is some kind of summary, but you want to give them all the detail because you think they'll need that eventually. As long as you break that into like, okay, here's the MVP, and you ticket up the MVP first, you can put off ticketing up the rest of it and get a quick finger in the wind understanding of roughly how big this thing is by breaking that first chunk into tickets that are executable, like something the team could go execute on. If I don't have tickets that are small enough for the team to execute on, I find it really difficult to like put any kind of, I'm going to use an oxymoron here, any kind of an accurate estimate on something. So that's my approach.
We'll be back with our interview with Alan in just a moment. Hi, it's me, Robby. Just want to take a quick moment to say thank you. Thank you for making time to listen to the podcast. If you're finding these conversations valuable or disruptive, annoying, delightful, please consider sharing a link amongst your peers and or writing a review on Apple Podcasts and Spotify to help spread the word. Also, is there someone in our industry that you think I should have on the podcast at some point? Shoot me an email to Robby with a Y at maintainable.fm. And now, let's get back to our interview with Alan Ridlehoover. Thinking about how, I'm guessing maybe I don't understand exactly how your organization, or, you mentioned you have 6-7 teams that report directly to you, for example, and then like, do they all have their own kind of product owners that they're working with, or do those share product owners across them or something? And then I'm curious about in that scenario where product owners or whatever that label might be in your organization, or someone that's coming up with that's deciding what new features or things are going to be working on, and then your team collaborates on working on an MVP for something. I often will talk with some teams where they'll be like, well, the product owners can only keep so many projects that they're thinking about conceptually in their head, or kind of like they're tracking in progress. So sometimes when you advocate for like, let's just do this small version of something, that sounds great to them in theory, but then there's also like, well, I kind of want to get this thing out of kind of want to push it over to the development team so you can start building this thing so I can go focus on this other big thing. And if I have several MVP things that we're kind of doing in parallel, then it's just a lot more for me. So I know what I want, please, to some, at least like 80% confident that I think this is what we need to do. Can you just go do this for a while so I can clear up some of my mental capacity while your team's building that for a while? Do you ever experience that sort of thing?
I have a couple of thoughts there. The first, I have the unique privilege of managing a platform team, or a set of platform teams, most of whom are focused on the backside of engineering where there isn't like customer facing stuff. Now, I do have some teams that are more front end focused, and like one of my teams is building a design system library. They do work directly with UX and with product managers on what do the components need to look like, what do they need to do. In that particular case, I'll use them as the example here. We have a single product manager that owns that. We have a team of UX engineers working with the team of our UX designers working with the team of engineers. And so the designers are very focused on a single component, and the engineers are generally focused on a single component at a time. And the product manager is thinking more about the like long-term release strategy, and will this MVP of this component make sense as a release or not? And so we have kind of a one-to-one relationship between, maybe not quite one-to-one, but we have designers who are focused on components. We have engineers who are focused on components one at a time. And we try to pair them up so that there's like a real focus on that one component. As far as my historical work that I've done with actual feature work, I find it most productive when there's a one-to-one relationship between a product owner and a team that's executing on that product. And so therefore that product owner is not multitasking across multiple things. They're in the trenches with the team. They're at stand up with the team. They're able to answer questions. They're able to keep the team unblocked. And that level of focus requires that one-to-one. You can't like have a product owner that owns 13 products.
That makes sense. Yeah, I'm just always curious how different teams kind of have that, or we just happen to have some clients that is a situation where they're kind of being spread across a couple of different projects in parallel, and we're a component of that for better or for worse. So I want to switch gears a little bit and talk about flaky flaky tests and their impact. And so, first of all, how would you define a flaky test?
A flaky test is a test that makes a bad assumption about its environment. There's something in the environment that is wrong as far as the test is concerned. And I think there are ultimately, I think every flaky test boils down to something related to non-determinism, but there are kind of three buckets that I put them in. There are those that are kind of simple non-determinism. Those are like system clock related issues. I swear dates are my nemesis. It doesn't matter how many times I try to get a date right, I always screw it up, even with tests. Some people are Boolean impaired, I'm date impaired. And then also things like network connections, those are simple things to correct. You just mock the thing, you mock the date, you mock the network connection. The next, I think, more difficult set of things are things that are order dependent. So where you have one test that runs and pollutes the environment in some way, and then a second test which is not expecting the polluted environment, it runs and it fails. But only when they're run in that order. If you run them in the opposite order, the test that would have failed doesn't, because the environment is in the state that it expects. Where you see this a lot is if there's any kind of global state being used. I ran into one time where a live caching system was in place between the tests. And so one test would cache something and the other test wasn't expecting it. But if they ran in the opposite order, it worked fine. Probably not. You probably don't want to use your live caching system between tests. And then the third, I think most complex, hardest to find, hardest to correct kind of flakiness is sort of race conditions. And these generally only happen on the build server. And so they're hard to figure out locally because, like I can't see what's happening on the build server. But there are tools that you can use in the Ruby world for those order dependency things. You can use it if you're using RSpec. There's a -- bisect option that will try to figure out which order of things will cause the failure. It's slow because it has to run the tests in multiple different orders, but it does work. And then for race conditions, something you can use, there's a tool called Parallel RSpec, which will essentially run the tests in parallel. And if you use it with order rand, so you're running them in a random order, then you can find you can actually run into the race conditions locally on your local machine if you've got the ability to run multiple threads at the same time. The things that generally runs into is like an exhausted resource on the shared environment. So like a thread pool that's exhausted or a connection pool that's exhausted. I think those are the hardest thing to figure out. Anyway, that's my take on flakiness.
How do you think teams can, these are some tools to help solve those problems. What sort of things do you think contribute to those things? Have you spotted any patterns things that you might avoid up front to kind of reduce the likelihood that those are going to occur?
I've spent a whole lot more time thinking about how to fix them. But if I were to riff off the top of my head, anytime you're introducing any kind of randomness into the system, you need to mock that in your tests. You cannot allow any kind of randomness in to the tests. They have to be deterministic. And so with regard to, say you're using a random number generator, just test around the edges, have a test for the lowest number, the highest number, and the edge conditions around that. If you're using a network connection, always mock that thing. Don't allow yourself to hit Google because Google's always live. Well, just hit the Google Maps interface and get the response back. No, mock it, because there will be a day when it goes down and you're like, why did that test fail? There's also, for some of the harder ones, the order dependent stuff, for example, make certain that you are don't use global state. There's too much of an opportunity for one thing to get in the way of another when you're running things in parallel across in different orders across multiple build servers even. But if there's some kind of shared state, a database or a caching mechanism or Redis or something, Redis is a key value store in the Rails world. If you're going to use something like that, you can't let your tests hit it. It has to be isolated, or like, for example, with databases, it's kind of easy to use transactions. So your test is running in a transaction, and at the end of the test, the transaction rolls back. So the next test is not affected by it. But if you're using a caching system or something like a key value store that doesn't have transactions, you either need to clean up after yourself, or you need to not use that particular technology within the test. And again, this kind of goes back to that interface thing, right? If you put an interface in front of that mechanism, whatever it is, you can mock the interface and get the result that you want from the interface instead of actually hitting the live tool in the back end. So just put a facade in front of it.
For those listening that might be working with some maybe lesser known APIs where their application's integrating with, and if they mock it, and then what sort of strategies do you advocate for keeping up on when those APIs might be changing and how to be aware of it so it doesn't first happen in a production environment? You're like, why is it broken all of a sudden?
I think that there are valid reasons to have tests that do hit the live system. This is exactly why you would do that. I don't think that those are unit tests. I don't think those tests run as a part of your test suite on every build. I think those are tests, they're integration tests that are run on some cadence, some schedule, just to make sure that the system still meets your expectations. So you expect the API to return this structure of data, and it did. You hit it and still did, yes, it still returns that structure of data. If you hit it and it returns something different, that's like a red flag. It's an error. It may have already happened in production, but at least now you know about it. And if you're running it on a frequent enough basis, you may catch it fast enough that the customers don't see it.
Yeah, it's always an interesting thing. I'm like trying to figure out how to advocate for how teams might structure something like that. Like you run your tests, but then are you building integration tests, maybe say back into like in your Rails application to do that, but then you might not be wanting to run that every time you're running your build and everything necessarily because it'll slow down. And so I think some people might not know when to do certain things. When do you actually hit the API, the real API versus hitting your mock scenarios? So does your team kind of think about that of like, okay, we've got some integration tests, but that when we run your default test suite, it's not running that unless we explicitly say test the live environments?
Yeah, so we have a couple of different kinds of test suites at Meraki. We have our normal, it includes more than just unit tests, it's unit and integration tests. We also have an end-to-end test suite. All of that runs as a part of the build process. We also then have a separate set of tests that not doesn't just do these service integration tests, but it also does like monitoring of is the login page up and running, and those things run on a cadence that is pretty frequent, but they're separate. We expect those things to flake and fail, and we don't expect anything in the regular test suite to flake or fail. That's an exception in that test suite. It's a normal part of running the business, and I forget what we call them. We don't call them integration tests. They're like live system tests is what they are.
And do those exist in the same repositories?
They do. Yeah, they do. They're not stored in the same like spec folder. Our spec tests in the Rails world, our spec tests live in a spec folder, and we store them in a system test folder separately.
Are there any other, you mentioned like the count of tickets that your team is closing and shipping on a regular basis. Are there any other data metrics that you find valuable to track the health of your software delivery cycle?
I want to try and understand bug rates, for example, so that this is especially important if you're using story points and you're not pointing those bugs. And there's a good reason to not point bugs because they're unpredictable. You can't look at it and say, it'll take me 10 minutes to find it because it might take you 10 days. And so in that world, I want to know what my bug rate is so that I can kind of predict. I can like pad my velocity by some factor to understand how much time we'll need for bug fixes. Most importantly, though, and I think this is kind of a little bit tangential to your question, I want to be monitoring everything, literally everything about my system that can be monitored. I want it on a dashboard in front of me and in front of my team. The most effective use of that I've ever had was at my prior employer. We had a messaging system that needed to be up. It was a major critical component for the entire application. My team owned it, and we went through the process of extracting it out of the monolith and into its own service. Once we did that, we got all this visibility into the system that we hadn't had before. So as a part of our daily stand-up, we stood in front of a giant TV screen. Obviously, we were co-located. We stood in front of this TV screen, and we looked every morning. How are things going? And if during the middle of the day we walked past that board and something didn't look right, we were on it immediately. It led to us solving almost every issue before a customer saw it. And it was just because we were on top of every data point that we had access to regarding that system.
That's awesome. Do you feel like that's as easy to do in a remote world?
I think so. As long as you've got like a dashboard somewhere in our case, we were rendering it on the TV screen, but you can render it on any monitor. And if you incorporate it into your daily stand-up as a part of the routine, then you're at least looking at it every day. In the remote world, what is a little bit harder is that you've got many windows open on your desktop, and that one might fall off. And so you might look for creative ways of monitoring stuff. So, for example, there is a tool that ThoughtWorks released many years ago called, I think it was called Cruise Control. They had a little widget that would either go in the tray on the Mac or in the tray on Windows that would just show you the status of your build server. And it was a red light, green light kind of thing. It shouldn't be difficult to give yourself that kind of red light, green light. I need to go look at this somewhere on your desktop, even if it's like leaving a window open and not covering it. Having some kind of visibility that's there in front of you all day long, every day, is really, really important.
Do you think it's as easy for maybe in your role where you're kind of keeping an eye on these things, it's part of your responsibility, and then on the individual contributors on your teams, like they're responsible for, I'm assuming their tickets, issues, however they're referred to in your organization, but to have this other place location they got to check on a regular basis, was sort of, how do you think about helping set those expectations? Like, you need to keep an eye here, and then also if since it's everybody looking at it at their own time, there's that scenario of like, well, who's going to raise their hand or volunteer to look into it? Or how do you know that someone else isn't already looking in it if we're all looking at the same screen at this, but we're not doing it in real time at the same time? You mentioned the stand up, and so that's maybe a good time where you have some, I'm assuming your stand ups are real time, given that you mentioned looking at them, but unless those are asynchronous, and then asynchronous world, I've seen teams kind of struggle with like, well, I thought someone else might look at it, or I started doing it and someone else started doing it in parallel, and then we didn't realize that we kind of wasted a little bit of time there, and so maybe I won't volunteer as quickly next time because someone else might already be on it.
At Meraki, we've tried many different things. And first of all, I never recommend asynchronous stand-ups unless there's just so many time zones between people that it's not feasible to be on the same. And in that case, I'm like, why did you separate the team that way? Build components and put each team in charge of components, and let the team in India do one and let the team in North America do another, and then do integration points between them. So that solves the asynchronous thing. With regard to how do we monitor these dashboards, how do we know that things are safe, and when they're not, who addresses them? You're absolutely right. If there's just the expectation that the ICs will look at these things, they'll get busy, they won't look. Even if they're looking every day at stand up, that might not be frequently enough. There's, I think, two things that help with that. The first is there's monitoring, but there's also alerting. And if you can set thresholds above which or below which there's a situation that needs to be investigated, then alert the team. And we've tried various mechanisms of that at Meraki. We've tried Grafana alerts that post directly to Slack, for example. And even then, like, somebody has to know to go check Slack because it's probably not in the team's normal channel because they can be noisy. And so what we found is that a tool like PagerDuty is much more effective at getting the team to take action. And you can set up a rotation of engineers so that somebody is always the on-call engineer. And you can set it up so that it only pages during business hours or whatever. Or you have a different team that responds after hours. Maybe if you're global like we are, you have teams around the world that respond in different time scenarios. And so, but the product team should be the team that owns the thing should be the first one to get notified if it's in their business hours. And I think the other thing we've tried and we've had some success with is that every company has a Slack channel that belongs to them. They have a public channel and a private channel. In their public channel, if somebody comes in with a question or maybe one of these alerts happens into their Slack channel, we appoint somebody to be the ambassador that week. And it's their role, not necessarily to pick up tickets on the backlog. It's their role to be ready and able to respond to that Slack channel, to the alerts that are coming in. And, you can handle that with a PagerDuty rotation as well. We've even got it set up so that there is one of my teams is called Ruby Platform, and there's in Slack there's an @Ruby Platform ambassador group that PagerDuty tells us who is in that group this week, who's in that rotation, and we have some glue code that'll update that group in Slack. Somebody coming into the channel can just @ the ambassador, and the correct individual will get notified.
Hey folks, it's Robby again. Just want to take a moment to plug my own company. Planet Argon. We're a software consultancy, and we help organizations improve their legacy software applications. Hence the podcast. We offer staff augmentation, and we provide fractional development services for those that don't need multiple full-time developers. We specialize in technologies such as Ruby on Rails, React, and Laravel, just to name a few. If you work at an organization or have in the past, and they're struggling with mounting technical debt, legacy code challenges, and are trying to figure out how to leverage the new features in their frameworks, can't figure out how to get to there, send them our way. Planet Argon is here to help modernize their platforms and make their applications shine. Visit us at planetargon.com. Again, that's planetargon.com. Let's get back to the show. A couple of quick last questions for you, Alan. So first, let's get some advice for our listeners. So let's imagine that there's a few people listening and they've been at their organization for a while and they might have feel like they've advocated for addressing some technical debt or removing some corrupt things that are slowing their team down. And they've heard not right now, maybe a few too many times in their mind. And so they've stopped asking to address these things, but they're listening to the podcast and they care about these things, but they're just like, I don't know, maybe I need to find a new job or something, or it doesn't seem like they care. But do you have any advice on how they might re-explore that today, how they might take some action on that?
I have found in my own experience over the years, and I've been doing this a long time, that when I approach the business, either the product manager or in some cases it was the CEO, because I was the only person who could make a product decision. When I approach them with, hey, there's this tech debt we need to address, I'm almost always shot down. But if I approach them and say, we need to do this upgrade because we are vulnerable to this kind of an attack, I get better response. Or if I approach them and say, I can give you this feature today, it'll take me 8 weeks. Or I can take 4 weeks to redesign this thing, and then I can get you the feature in 2 weeks. So if I come to the business with trade-offs and allow them to make decisions about trade-offs, I'm usually more effective at getting what I want. So the vulnerability one's more of a threat. Like, if we don't do this, we're susceptible to this thing. And I want that to be your decision, not mine. I didn't make this decision. I made you aware of it. So if we get attacked and that happens, we'll both know who made that decision. But yeah, really coming to the business with options and explaining the ramifications of each. And often if they're like I said, if you know that refactor is going to make it simpler to add that feature that they've asked for, tell them that. Make them aware of it. Let them know that giving you a few weeks to solve this technical challenge will make it so much easier to solve the longer-term challenge or to build the new feature. In fact, that's exactly what we did with the extraction of that messaging system out of that monolith. We were given a feature requirement that was going to take us probably 6 months to execute on. And we said, look, if we can extract the service and sort of re-architect it a bit, we can totally do that in 4 months instead of 6. And that got us the permission to go do that work. And we did. We pulled it off. So
I think that's some really solid advice for our listeners. Curious kind of follow up to that. It sounded like, well, I guess maybe I was thinking like when you're thinking about those estimates, like, well, if it's going to take 6 months to do it like this way, but if you give us some time to do it this, we can do it faster. Were those scenarios still going to yield a longer time frame than the original? Like, you know what I mean? If it's like, well, if we get some time, there's just more about like, say, in the future, we're going to be able to do more things quicker as well. And that's going to be beneficial to everything versus being like, well, this will be faster. So I'm like, why would the CEO say, oh yeah, we'll do whatever the fastest thing is?
So my take on that, I've been in management for a while now. My take on that might be a little bit more management centric at this point. If you have debt that is hindering my ability to request new features, then I absolutely want that debt addressed. If you have debt that is not currently hindering my ability to get new features, I think there's a scenario there where it makes sense to just let the debt sit for a little while longer. For example, Sandy Metz is kind of a luminary in the Ruby community. She has a great talk. Let's see if I can remember the name of it. It's not coming to me, but there's a portion of the talk where she talks about this thing called an omega mess. An omega mess, according to Sandy, is some piece of code that has giant complex algorithm in it that's really messy. It's got a ton of conditionals and you'd love to refactor it, but it works. It may not quite have enough test coverage to make sure that if you were to refactor it, you didn't break it. As long as there's nothing changing in that area, there's no reason to touch it. Leave it alone. It's not responsible from a business perspective to just go off and do that refactor. It makes a whole lot more sense to wait until there's a need to change that thing and then come in and backfill the tests and refactor the code so that you can make the change that I think it's Kent Beck said, make the difficult change and then make a difficult change simple and then make the simple change. I think that's the way it says. And if you are struggling with that large complex algorithm and it's really bothering you, just close that window in your editor, let it exist and let it be okay because it's working. And the business has only so much money that they can invest and so much time of yours that they can invest. And it doesn't make sense to fret about it when we live in a commercial world and commerce happens.
As we wrap up, Alan, a couple of last questions for you. Is there a non-software, non-technical book that you find yourself recommending to peers?
Yes. I read Radical Candor years ago by Kim Scott, and I think it changed the way I interact with people. Like it talks about being really direct with people about what needs to happen, but also it talks about building relationships with people so that when you are direct with them, they understand that it's coming from a place of caring and coming from a place of sincerity so that they don't just write you off as, oh, he's just being a jerk. It allows, by being caring and by being open and creating relationships with people, you're giving yourself and them both the ability to be direct, to be kind about it. And like being direct is the kind thing to do. If you beat around the bush, if you don't say the thing that needs to be said, whatever issue it is just going to perpetuate. That'll lead to animosity and perhaps bad business outcomes. And so you're better off to be direct. But in order to be direct effectively, you need to be building relationships with people and making sure that they're aware how much you care about them and their success.
I'll definitely include links to that in the show notes for Radical Candor. You're definitely not the first guest to recommend that book as well. And I've read it and I recommend it as well. Where can listeners best follow your thoughts and ruminations on software engineering online?
I have a blog. It's called the.codegardener.com. And everything I think about software that I have time to write about lands there.
Awesome. Definitely will include links to that for everybody in the show notes as well. And with that, it's been such a delight having you join us on Maintainable, Alan. Thank you so much for stopping by to talk shop with us.
Thank you, Robby. And just before I go, I want to say this is my favorite podcast. I really enjoy it. I learn something every time I listen to it. So thank you.
Well, I really appreciate that. Thank you. And thank you to all of our wonderful guests and listeners. And make sure you get out there and rate us on Apple Podcasts and Spotify.